Hello everyone. Complex number is represented by the letter J. The definition of J is J equal to the square root of -1, or J square is equal to -1. Before I start with example number 1, simplify J to the exponent 109, I would like to review the formulas related to exponent. So if you multiply 2 power with the same base, so what you do is you write the same base as a and you add the two exponents. So this is the first formulas. The second formulas, if you are raising a power to exponent n, and what you do is you multiply the two exponents. So we use the concept in these two formulas to apply to simplifying j to the exponent 109 and also j to the exponent 88. Alright, so let's write this down. J to the exponent 109. So what I do is, in order for me to simplify this, I have to base on the definition of j. So I have to base on this, or I have to base on this. So what I do in this case is I will break this exponent into 2. So I will write it as j to the exponent 108 times j to the exponent 1, because 108 add 1 will equal to 109. I apply these formulas right here. You probably ask me why I break it into these two powers of j. The reason I'm doing that is 108 relates to number 2. I can write it as j squared, all of it to the exponent 54. Because 2 times 54 will give me 108. Because from here, I can apply the definition of j squared equal to -1. So now, instead of writing j squared, I will replace that with -1. So I take -1, I raise that to the exponent 54, and then I times that with j. So in this case, now you see, -1 raised to the exponent 54, you can use your calculator, or you understand that if a negative number raised to an even exponent, you will have a positive result. So you will have positive 1 as the answer, time that with j, so your final answer should be j, or you can write it as square root of -1. Alright, so let's continue with example number 2. Here I have the even exponent. I raise j to the exponent 88. So again, using the same concept, I have to apply the definition of j. Therefore, I will write j squared. In this case, I will raise this to the exponent 44. Because I know that 44 times 2 will give me 88. Because I'm using these formulas right here. Okay, so what I'm going to do next is replace j squared by -1. So I take -1, I raise that to the exponent 44. Remember that -1 raised to an even power, therefore I should have positive 1 as the result. Okay, so in this case we are simplifying j. You can raise j to certain power and apply this concept in order to simplify j. So how does that work? How can we visualize this number j? So what I'm going to ask you to do is to take a look at this graph, and I'm going to introduce to everyone the graphical representation of a complex number. And in this case, what I have is I will analyze the rectangular form and the polar forms. So as soon as you have a j, it's representing a complex number. And if you attach it to a coordinate on the x and y axis, you are having a rectangular form. So in this case, this form right here is the rectangular form. So for rectangular form, it's a representation right on this graph. So here is your y-axis, here is your x-axis. And what I will do, I will attach the j with that to tell you that it is a complex plane. Alright, so I will have y times j, and down here I should have y times negative of j. Okay, so here I have x, and here I should have negative x. There are two parts for this rectangular form. So in this rectangular form, what I'm going to ask you to do is to pick a coordinate on this graph. So in this case, what I will do, if I will pick this coordinate right here. Okay, I pick this coordinate, and I'm going to identify that as x and y. Okay, label this as x and y. So if I attach the j to this, I will write this complex number as x plus yj. Okay, so let's draw this complex number in polar form. So from this point, what I do is I will connect this with my origin. Okay, put a vector symbol to this. This is called the r, okay, which is the modulus. So I will identify this here for everyone. So this one is a modulus. And if I identify the angle theta, so I will pull it up like this. This is my angle theta. So I present this one as r with the angle theta. So this is my polar form. So this form right here is called the polar form. Alright, so rectangular form and polar form. So label that. So here I will call this one is rectangular. And this one I call this a polar form. Okay, so let's talk about these two forms that we just found on this graph. And we draw it to identify it as well. So first of all, the rectangular form of a complex number is the coordinate that you have right on this graph, represented by the coordinate xy, and you can write it as x plus yj. Okay, so x is the value on this x-axis, and I call this a real values. And y attached with the j is on the j part of this complex plane is called the imaginary part. Okay, so we can call this one as imaginary. And this one, x is real. Okay, so for rectangular form, you will have the real part and the rectangular part. So here is your real part. So this one is the real part of this complex number. The one that attached with the j is called the imaginary part. Okay. For a complex number in polar form, what you have is r, which is the magnitude of this vector. Okay, the magnitude of this vector from the origin to this point. So what you have is r is called the modulus, which is the magnitude of this vector, and theta is the argument, which is the angle in standard position, go counterclockwise starting from the positive x-axis. Alright, so what I have in this case, polar form, then what I need to identify for you is if I have r, okay, and then theta, so this one is the modulus, this one is the argument. Okay, the argument in this case you can have it in degrees. Okay, now so let's examine another complex number. Let's say I bring my I move my pointer to this part of the graph. So I identify this point right here, the coordinate on this point. So I should have negative x and negative j, right? Okay, so in this case, my complex number in rectangular form should be, okay, negative x minus yj. Alright, okay. How do I represent this one as a complex number in polar form? Again, in polar form, you will have to be very careful. We will start from the origin 0, 0. You draw a vector to this point. Okay, put a vector on top of that. And this is my r for this particular complex number in rectangular form. And how do I identify my argument? Is again, I will start from the positive x-axis, go counterclockwise, and stop where the sign for the modulus is. So in this case, this is the angle theta. So I will have the complex number in polar form as r and theta. So now you note that because r representing the magnitude, therefore r is always the positive values. Alright? Okay. Theta can be negative as well. If we are talking about the angle as clockwise, if we go counterclockwise, theta is positive. If you go clockwise, then theta is negative. Okay, so let's talk about that. So I'm going to pick another point on this graph. So let's choose another color. Okay, so I pick this point right here. Again, for this point, I will identify my rectangular form as x and negative y. So the rectangular form in this case would be x subtract yj, right? Because I am in the negative part of j. And from here, I will draw a vector, or they call it a phasor, to this point. Identify this as r as well. Okay, so if I draw my angle like this, so I'm going to go like this, I go clockwise, then in this case, I will call this one as a negative angle. So let's call this one as theta 1. So right here I should have theta 1. If I call this one theta 2, I should get this as theta 2. And I call this one theta 3. Then my answer in this case would be r and theta 3 to represent this particular vector that I just drawn. Alright, okay, so let's move on to the next example. The next example I am having in this case is I'm asking everyone to use the calculator Casio FX991MS to convert between rectangular form and polar form. So let's say I am giving you a complex number in rectangular form. I will ask you to convert to polar form. You can use trigonometry to work with this. However, it's complicated. Therefore, I think we should use the calculator to help us. Alright? Okay. So, let's say I have 3 and 4. 3 and 4. So let me quickly draw the graph for everyone to visualize it. Okay. So, I'm talking about this particular example right here. Okay, I will show everyone the calculator in a minute, but before this, I would like everyone to visualize what I have in this case. Okay, so I have a graph, x and y. Okay, so here x, here yj. So don't forget to attach the j to represent that it is a complex plane. And on here, you see that the rectangular form is 3 plus 4j. It means that x is 3 and y is 4. So 3, 4 is somewhere on this graph. So if I have 1, 2, 3, 1, 2, 3, 4, so I should have it's around here somewhere. Yes. So it's x, y. So in this case, I should write this one as 3, 4, right? So x equal to 3. Y equal to 4, and the rectangular form would be 3 plus 4j. For the polar form, you can see that it represented by this is 5 and the angle 53.1. So what you have is you are going to draw a vector from the 0, 0 up to this coordinate 3, 4. Okay, so right there we do that. And r in this case would be 5, and the angle theta in this case would be 53.1. So you see, this is the complex number in rectangular form, also in polar form, and vice versa. So how do we find this using our calculator? So I would like everyone to go over all this stuff, okay? Get your calculator out and go over all this stuff. And also you can convert from polar to rectangular as well, using the same magnitude for the r, the same argument, and the same coordinate. So to make sure that we do it right. Okay, so let me show everyone the calculator. So right here is our calculator FX991MS. So it's probably slightly a different version than this one, but all the function keys should be the same. So what we need to do is you are going to concentrate on the shift key. Okay, the shift key, you press on that, that means you are going to pull out either rectangular and polar on top of these two keys. Okay, so I believe that should be it. I just have to make sure. No, I'm sorry everyone, because it's too light for me to read. Okay, so I have an actual calculator in my hand, and I think the rectangular is this one. Okay, it should have the rec as rectangular, and then this key right here, it should have a pole for polar. Okay, so basically what you do is, first of all, everyone press the shift key, and I'm going to do that on mine as well. I put shift key, so then I will have an S appear. Alright, and then what I have to do next is I will press pole. That means you are going to use this key right here. So watch my pen, I'm pressing this key, pole. So you will see that it appears this on your calculator. Okay, press this bracket, it's already there. So there's a bracket, but it's already there. So what I will do is I will put in 3. So you press this key 3, this 3. Okay, then you are pressing the key number 5. So I'm going to use my mouse to show everyone. So here, this is 5. Okay, and also this comma is right here. Okay, so this is 5, this is comma, so I will put in and 4. So here's the 4. Okay, so we are doing both of this at the same time. So let me convert from polar to rectangular, the rectangular to polar in this case. So what I have is I have to put in 3 and 4. Okay, so I press the 3, I should have the 3 as the answer. And I press this, I should have a comma. So 3, comma. And then I press this 4, I should have a 4. Okay, and I press this key to close the bracket. So I press that, and now you press the equal sign, and you see the number 5 will appear. Okay, so after you have number 5, you know that 5 is the modulus. Okay, so how do you get the angle now? Is to get the angle is to use this recall key on your calculator. So this is the recall key. So I press that recall, and I will press tangent in this case. So I press tangent, and then all this 5 will disappear, and also let me I just have to find the eraser on my screen. Okay, so this will disappear as well, and what I have in this case, after I press that, go with F equal to, and you see that 53.13010.235. So what you have is, this is actually the argument, and it's in degrees. Make sure your calculator is in degree, so that you can have a proper calculation for this. And I also would like everyone to turn off your engineering notations. Okay, so if you have engineering notation on, it may not work when you work with the complex number converting between rectangular and polar form. So you make sure you turn your engineering notation off. I know that if you are in electrical electronics, you always have to have the filter of engineering notation on, but I strongly recommend that you are going to turn that off. Alright, okay, so let's continue with our lesson. So let's go back to our lesson. So I would like everyone to go over this example here also, and this one, using your calculator to make sure that you master the key how to convert between rectangular and polar form. This is very important, alright? Okay, so let's move on to example number 3. In example number 3, what I have is I have an expression, and I would like everyone to convert this expression as complex number in rectangular and in polar form. So in this case, in fact, it's very simple. Okay, so what I have is I will write -5, and then what I will do, I will break this square root into 2 components. I will break this into square root of -1 multiplied with the square root of 9. Okay, so because square root of -1 multiplies square root of 9 will give me the square root of -9. So in this case, what you see is you can use the definition for the complex number. You can replace the -1 as the square root as the letter J. Then you take the square root of 9, it should be equal to 3. So you can rewrite your expression as -5 minus 3 times J. So now you are having this in rectangular form already, right? Rectangular form where you have x equal to -5 and you have 3 equal as -3 is equal to J. Now use the calculator to convert this into your complex number in polar form. So use calculator to convert to polar form. Okay, so I assume that everyone have the calculator already. Then in this case, I will give you the solution for that. Okay, so what we have is again, so we are going to press certain key. So because I'm converting from rectangular to polar, so I will press shift. Okay, so I press shift. I will press pole, shift, pole. I will put in -5, comma, -3, and close the bracket. Okay, so let's go to our calculator, and I would like to quickly show everyone how to do this. Okay. Alright, okay. So first of all, engineering notation off, and you should have degree. Alright, okay. So press this key, shift. So here shift, here pole, okay. And then you will have a pole on your calculator. Now, -5, this is your negative key. Don't forget that is the negative key. So this here is a subtraction key, so don't use that one. Use a negative. So I have -5. I press this key to have a comma. I have -3 in. Close the bracket. I press equal sign. I should have 5.83. Okay, so 5.83 as the modulus. Now I'm going to get the angle or the argument. So I'm going to press recall. Recall is this button right here, and I press tangent. And press tangent, I should have it as -149.0362, but in this case I just write -149 because I would like to present this as 3 significant digits. Alright, so let's get back to our slide, and I want to write this down. So in polar form, I should have this one as 5.83. Okay, so it will be 5.83. The angle is -149 degrees. Okay. So let's present this one as a graph. Okay. So how do I sketch the graphical representation of this complex number? So let's take a look at that to see what we have. Alright, okay. So let's move the screen over a little bit to the side. Okay. So what I have is I need to record the video in 30 minutes only. So I only have 5 minutes left. So what I will ask everyone is everyone will work on example 4 on your own and try to get the solution for this. I will quickly write this down before I will get to the complex number, the graphical representation of the above complex number. So I will write quickly the answer for everyone. A469 minus 2.3640J. Now in 3 significant digits, so it will be minus 1.85 subtract 2.36J. For this one, in 3 significant digits should be 11.3. The angle would be negative 119 degrees. Okay, so let's go back to our graphical representation of this complex number. So that means I should have my graph ready. Okay, so I will have my graph ready. Alright, okay. So label this as X, okay, real, Y, okay, J as imaginary. And if you have negative 5 and negative 3, your answer should be around here. 1, 2, 3, 4, 5, negative 5, negative 3. So there is negative 3. So label this one as negative 5, negative 3. Complex number as rectangular is negative 5, subtract 3J. Okay, so this is in rectangular form. And for the polar form, what we have is you are going to draw this modulus out, okay, like that. So R in this case should be equal to 5.83. Okay, how do we present this as a theta? So starting from the positive x-axis, go counterclockwise. This angle should be a positive number. So theta should be equal to 211. And how about the negative angle that we found using our calculator? Then what we do is you are using clockwise, you are going this way, and this angle would be your negative 149 degrees. Okay, so um, it's just my phone, I'm sorry. Okay, I should just turn that off. So thank you everyone. I almost get to my maximum time. So I would like everyone to start working on practice for lesson 1, and solution is actually posted online. Alright, thank you.